Something important happened for Simulink. UniPlot opened the doors to a seamless and powerful simulation data analysis. You want to know more? Here is a template from the Simulink library. As you can see, it is an automatic transmission controller. Let's change a bit its parameters and run a simulation. Our new Simulink connector appears at the end of the simulation. The data is sent directly to a template which uses all UniPlot power. Here, for example, we have a table where we compute minimum and maximum on Y with conditional formatting, we use magnifying report, we do peak detection, and this is only part of what you can do with UniPlot seamlessly with Simulink. But how can you do that for your own models? That's what we are going to discover today. After starting MATLAB, click on the App tab in the ribbon and Get More Apps. Next, type UniPlot in the search bar and you will get to the UniPlot as a post-processor application. Click on it and simply add it. Once installed, it should show up in the ribbon on the top where all your apps are stored. Before running it for the first time, you should start a Simulink model. I will use the same one I used earlier. Here is the model, and before starting, go back to MATLAB and start the application for the first time. This window will show up, show you that UniPlot has been properly detected, show which workspace is being used. There is one coming by default with the application, but you can modify it, and select the sequence to run. We'll come back to that after. If you don't have UniPlot, feel free to go to our website and get it from us. And finally, click on Get Your Model Ready to be sure that the application will be called at the end of every run. It's done. I go back to Simulink. Now you can see I have a UniPlot tab with the Run button, which is the same as you find everywhere else in Simulink, and the UniPlot button. No need to open it. You are now ready to use UniPlot as a post-processor for Simulink. It all starts by telling Simulink which variable to register. For that, we are going to use a built-in functionality. Select all the branch you want to register and click on Log Signals. All the log signals will be available in UniPlot. Once this is done, you can click either on this Run button or the one in the UniPlot tab and run your simulation. At the end of the simulation, the app will pop up. We can confirm that the setup is fine and we give a name for the run. Let's call it Base. We'll focus on the rest after. Just click on Send to UniPlot. UniPlot starts and give you a bit of information. Here, in this case, the data has been loaded in the data browser. UniPlot tells us to drag and drop a channel to plot it. Okay, let's focus on UniPlot. And here we can find all the channels that we have in MATLAB available to plot. Let's make it wider and let's create a new document. So let's plot the engine RPM. I want to add a picture like I did in my example. I just select that. Go back to UniPlot, paste it. And that's where setting a file legend. Add legend for data file. Let's make it a bit bigger. Okay, that was the first step. I will go back, run another simulation after changing some parameters. So my example of before, I increase the drag friction and I run. The app pops up again. call it a high friction. And now we are going to focus on the second part. We had a view sequence in our Simulink workspace or a compare. I'm now going to compare. And side note, you can add runtime value. If you're used to the sequencer, which is UniPlot code-free automation module, you know that runtime value are really useful to add extra functionality to UniPlot. So let's add one. Let's call it export, and let's set it to 1. And now we send to UniPlot. The data has been added to UniPlot, and indeed we can see the result base and the result high friction and compare them. Comparing visually is of course the most basic UniPlot feature, but I strongly recommend to dive into the numerous other it offers. Of course, the cursors that you can display, then move and get some basic information on your data, peak-to-peak data, mean, area under the curve between the cursor. But apart from the cursor, there are much more exotic ones that I'm gonna present right now. For example, you might be interested in peak detection. Right-click on the curve, new data set, and find peaks. Okay, and you find all the peaks. Now let's go a bit further. Right-click, text object, 2D table. You get a table of when the peak happens and the value. Pretty interesting, no? To get a quick view of your data. But that's a simple one. You can apply much more complex filter. Example, let's work in a new page. Let's plot the output torque. I will apply a special filter, the extract range special, and I will ask UniPlot to tell me all the points that are above 600 Newton meter, and that creates a Boolean channel that is at 1 when the condition is true. I will display this in another axe, and I'm getting it here. Let's do a little bit of formatting. You can see the kind of nice setting you can use to make interesting reports. And we have our peak detection. And now on top of that, let's apply another filter, which is the event duration. And now you get a new data set where each point represents an event above your condition, and the y-axis is the duration. Let's create a table, text object, and 2D table. And we now have a table where on the left you have the event, and on the right the duration. And we can add a conditional formatting saying that when the duration of the event is above 10 seconds, we want a red flag to be sure to detect dangerous event for the transmission. And here it's done. And of course, that's not all. You can create formula, do unit conversion, name conversion, you name it. And if you want to know more, you can assist our webinar, contact us, or check the documentation. What's behind all that? Well, the sequencer. As I told you, the app is coming with a default sequencer, the Simulink workspace, where you have the view sequence and the compare sequence. If you look in detail, you will see what's happening behind the hood to make it run. But you can modify it, make a new one so that every simulation data is analyzed as you wish. And by the way, we click here, we can see that my export runtime value has been added, and I can make a condition so that, for example, the template is exported to PDF or not. And this way you see how easily you can interact between Simulink and UniPlot to use all the tricks available in UniPlot to get the most of your simulation data. Thanks for watching us. For any question, contact us at support@uniplot.com. Come and check our website www.uniplot.com. And click on the logo to follow us on LinkedIn and get fresh news of UniPlot.